Okay, let's start working on some of this simulation logic. So we're in here in our terrible instruction list, which we hate using so much, and let's go ahead and set this thing up. So first thing I know I'm going to need a 500 millisecond timer. That's going to be my update timer. So let's go ahead and call something called update timer. And that's going to be a TON. Alright, and now that I've got that call, I need to go in before there and I need to set some things up. So let's go ahead and load a value, and that's going to be T pound 500 ms. And we're going to store that into our update timer dot PT. And then we're going to conditionally energize that, but we also need this timer to self-reset. So here we go. Let's go ahead and load update timer .q, and actually we're going to load the opposite of that. So let's go ahead and load in, and then we're going to store that into the input. So we're going to take our update timer .in, and we're going to store the opposite of Q. So as long as we haven't timed out, then we're going to go ahead and run that. But before we do, we also need to know if we've got Q. So before we load the opposite of Q, let's go ahead and load Q itself. So update timer .q, and we're going to store that into refresh underscore trigger. Okay, so that's going to tell us to refresh our values. That's going to be a bool. And then after that, we're going to update the status of the timer, and then we're going to call it, and everything's going to be great. So now we have a refresh signal, which is going to tell us whenever we need to actually do something to our numbers, and that's going to be real easy to work with. So we can go ahead and load our refresh trigger, and we can jump conditionally to update values. Oops, not blues, but values. Got it. And assuming we don't update our values, then we're going to just go ahead and return. Perfect. So let's come down here and let's start looking at our update values logic. Put a colon on the end of that. Now, what do we actually need to do? Well, we're going to modify our temperature in signal and our level in signal depending on the status of the devices on our system. So what is that going to look like? Well, let's start by loading temperature in. So load, we're going to take our PLC program dot, and we're going to look for our temp signal coming in. And then I'm just going to go ahead and skip down here, and I'm going to create a load also for our level coming in. So PLC program level, and I'm looking for level in. That's our 0 to 16383 PID scaled real. Okay, so what do I want to do with this? Well, the first thing I want to do is I know that temperature naturally drops. So I'm going to go ahead and let's evaluate this and see if we have room to drop. So I'm going to type GE to see if we're greater than or equal to 70. And if we are, then we're going to jump C to drop temp. All right. And if we are not, well, then we want to go ahead and go to our drain tank. So we're either going to drop temp or we're going to go straight to drain tank. And I need to put a JMP in there. Got it. Okay, so coming down here, we need our drop temp routine, our little label here. And then down here, we're going to need our drain tank, colon, got it. Now, dropping temp, what is this going to look like? Well, in case it's not still loaded, we're going to go ahead and I'm just going to put in one more load on that to make absolutely sure that that's what's on our plate still. And actually, yeah, the last thing on our plate was going to be this greater than equal to. So we don't want that on our plate. We don't need a bool. We want the actual temp for coming in. And that's not a temperature. That's a 0 to 16,383 value. So that being the case, we don't need to be looking at the temp signal coming in. What we actually need to be looking at here is temperature, because we're comparing that to 0. This isn't going to be 0 to 70. This is going to be what we're actually working with is the input signal. So what we're saying now is if our actual temperature is less than 70, then come down here and then I'm going to work with my input signal. Okay, got that cleared up. That's one more bug that we've fished out before we actually started running. Well, what we're going to do is we're going to take our LD and we're going to subtract from it. So let's go ahead and put in a subtraction, and what we're going to subtract is our PLC program dot, and that's going to be our drop heat value. So there we go. So we've just subtracted drop heat, and then we can go ahead and store that into temp heat. So let's put a store, and we'll call that, actually we'll just call that temp, I want to say temporary temperature, but that doesn't work, so we'll just call that local underscore temp. Got it. And that's going to be a real. Now we have to ask ourselves questions. What's going to change this heat? The first question is the heater on? The second question is my pump on? Because both of those are going to change our temperature in different ways. So we've already looked to see whether or not we could drop temp, and we did. And if we didn't drop temp, then we said we're going to go to drain tank. Well, we actually need to go to something else. So first, let's go to heater check. And after this, we'll put that heater check in and put a colon at the end of that. So now we've just made one small adjustment to our drop temp. And actually, let's do one more thing. We only want to do that on refresh, and okay, that's going to work. So if we don't refresh, we're going to return. We're good on the refresh. Okay, so anything below this line is only going to happen once every 500 milliseconds or twice a second. So after drop temp, we're going to come down to heat check. And in here, let's see what's going on. We're going to load, and we want to see what? We're going to check our PLC program dot heater, and we want to see if our heater's running. And if it is, then we're going to jump C to, and that's going to be raise heat. Otherwise, we're going to jump C to, and this will be pump check. So otherwise we will jump to, and that will be pump check. So let's come down here and set raise heat. And we don't have a raise heat yet. Okay, so that's good. So once we come down to this, now instead of checking, we're going to actually pull in this again. So now we're actually changing our temperature. So let's copy this logic, come down here, and we're going to load the temp in. But now, because we're raising heat based on our heater, we're going to add. And what are we going to add? Well, this is going to be our heat up factor multiplied by some small amount. So what have we got? Well, we've got our up here, let's look at how we want to manage these numbers, because there's 100 ways you could do this. If we're going to drop temp, we are going to drop a certain amount every time. So right now we're just dropping our drop heat factor, and we'll go ahead and, that could be anything. But when we come over here, we're going to add something, and that's going to be our heat up. So let's go ahead and put that in. So we're going to add heat up into our local temp, and then after that, what are we going to do? We're going to store that new value into our local temp. Well, actually, we don't want to be starting with this temp in. We really want to start with our local temp, because presumably we might have already managed that. So that being the case, just in case we don't actually do a drop temp here, when we come up to update values, this is where we really need to set our local temp. So we're always going to come into update values, and before we start evaluating things, let's go ahead and pull in and set our locals. So we're going to start by loading, and that's going to be PLC program dot, and we're going to get our temperature, and we're going to store that to, and that's going to be our local temp. Then we're also going to load, and we'll go back to PLC program dot level, and we're going to store that as local, and we'll just say local LVL. Okay, so now that we've got those both set up and both reals, then when we come down here to drop temp, we don't even need to look at anything like pulling in our program temperature. We're just going to start right away with our local temp. So we're going to take that, we're going to subtract our drop heat value, and then we're going to store that right back into local temp. At the end, we'll send all these values back into our main program. So after we decide whether or not we need to drop temp, then we're going to come to heater check. So one way or another, after we drop temp here, we're going to come to our heater check, and we're going to check and see if the heater's running. If it is, we're going to raise heat. If it's not, we're going to skip down here to pump check. So let's pretend then that we do need to raise the heat. We're going to come over here and add our heat up value, and we're going to store that in our local temp. But again, we don't need to use an input. Now we're actually just working with our local temp. And that's not actually the temp, that's actually the local input signal, but that's okay, you already know that. So after this, now we've raised the heat. Now we're going to come into our pump check, and this is actually going to drop our heat a little bit faster. So coming into here, let's see if we need to actually do anything. So what we need to do is we're going to do another check. So let's take some of this check logic, and instead of the heater now, we want to check our pump. And based on our pump, we're going to either reduce heat, or we're going to go to drain tank, or we're going to go to drain tank. So that should work. And let's come down here and create our reduce heat label. And here we're doing another temperature subtraction. So let's select all of that and paste it in here. And now if we're running this pump, we actually want to reduce it a little bit faster. So before we pull in our local temp, we also want to come up with a bit of a factor. So let's start by loading our drop heat value, and let's put an LD in front of that. We're going to load drop heat, and then we're going to multiply that by, and we'll go ahead and multiply that by 3. And we might end up changing that later on, but we will find out. So now that we have that, let's go ahead and store that, and we'll call that just something simple like redux, because we're going to be reducing by that much, and that will be a real. And then we can load our local temp, and what we actually subtract out will be this reduction figure, and we'll store that back into the local temp. Okay, so now we've got all of our heat going on. Now we come into drain tank, and we need to look at actually making that tank level change as well. So we've got heat up, drop heat, and now we need a fill rate and a drain rate. So coming into drain tank, we're going to check a few different things. And actually, I don't think drain tank is a really good name for this. So for now, we're really not going to be draining the tank. What we're actually going to be doing is we're going to be checking the valve. And let's go ahead and call this valve check. And copy that and come back up here where we were jumping to that. We were jumping to that after the heater check, and actually we don't need to jump there. We need to jump to pump check. And then, okay, we're going to run into pump check anyway. And let's go back up to the top, because there was one other place that we were jumping into that. We were either going to drop temp or not. And if we can't drop the temp, then we can go ahead and go to pump check. And actually, there's going to be a limit on this tank as well. We can't actually drop unless we're below a certain place. So we can go ahead and call this level check. Sorry to keep changing names on you, but I'm really just trying to get this thing halfway right. I'm sure it's going to be buggy anyway, but I'm trying to do the best I can. So instead of pump check, we're going to call that level check. And let's go back up here and call that level check as well. Okay, so now we're going to get down here and have to check our level. And we're going to check to make sure that there's something in the tank, because obviously we don't want to be at 0 level and still draining ourselves into negative values. We also don't want to be up to 100% and still filling ourselves up and going up to 200% level or something corny like that. So we're running a little bit long once again. Let's go ahead and take another break, and we'll come back, and well, this is going to take as many lectures as it's going to take. What can I say? So that's okay. We'll keep going, and you can forgive me later. So I'll see you in the next lecture.